continue to the part 4 video of this exercise 5.1 as it was written in the first few videos. Now we are with the same continuity, we are with the same concept of continuity.
Yes, that they give us, you have to find the points of discontinuity. So let's check how to get this. Over here we have f of x equal to modulus of x by x, where x is not 0 and it is 0 when x is 0. I've told you that places where there is a difference, where the function is defined differently, that is a place where we will first check for discontinuity. More or less in the other places it will be well behaved and it will be continuous. So once we check for this area, then our work is done. Another thing is modulus of x, always you have to check in the left side of x, left side of 0 and right side of 0, because they behave differently. So there are all chances that the function may become discontinuous depending on how it is defined. So our first thing is to calculate the limit from the left hand side of 0 and limit from the right hand side of 0 and check how it is. If it's fine there, then it will be more or less continuous function. So let's start right away at x equal to 0 if you want. And let's consider limit as x tends to 0 minus. We understand what is 0 minus. If this is 0, then this place is what is 0 plus and this place is 0 minus, neighborhood, very very close to 0. So f of x, so that is going to be limit as x tends to 0. 0 minus is on the left side of 0, so every function is negative, so automatically the modulus function is going to be the minus of that function. That's how we understand that. See, we know that modulus of minus 5 is 5, but how this 5 has come, when this minus 5 is supplied with one more minus, that time it becomes positive. So that is why when you have to remove the modulus from a function, for a negative value you have to supply one more minus, and if it's a positive value it remains as it is. So that we have to keep in mind. Now it is very clear to us the x here is negative, so in order to remove the modulus we have to supply a minus, and here it will be as it is. Like that, this will get cancelled. Limit as x tends to 0 minus 1 is always minus 1, yeah, value will be minus 1. Then we will consider the limit as x tends to 0 positive, means right side of 0. Let's see how it comes. It is limit as x tends to 0. Modulus of x will be x, because positive, doesn't matter at all, x. So that is 1. Like that, the limiting value is 1. See right away, left limit is something, right limit is something, they are different values, so it is not continuous. So therefore limit as x tends to 0 minus f of x is not equal to limit as x tends to 0 plus f of x. Therefore f is discontinuous. That's what they ask at x equal to 0. That's what they have asked us. Where is it discontinuous? Okay, so this question number 9 we can go. It's just like question number 8 only, a little bit of alteration. I need not write the question, but I will start from there, right? So solution, same way, there is a problem at 0, so let's check the left hand side and right hand side of 0. So consider first the left hand side of 0 or the right hand, then we take the right hand side of limit as x tends to 0 minus f of x. That means limit as x, it's a negative value, we all know. So x will remain as it is, but modulus of x will become minus x, because it is on the other side of 0 where all values are negative. If the modulus has to come out, you have to supply another minus, and that's how you will be getting the value there. So that's how this is coming up. Automatically this is coming up as minus 1 when we do it. Limit as x tends to minus 1, minus 1, and limit as x tends to 0 plus f of x on the other side of 0. That is limit as x tends to, after 0, please see the definition, on this side and on this side. On this side it has got a definition, but on the other side, no matter what comes, it's a constant function, minus 1. So we are not bothered, it's minus 1. The value is minus 1. It includes 0 also. F of 0 is also minus 1. So actually it is continuous. So therefore limit as x tends to 0 minus f of x is equal to limit as x tends to 0 plus f of x is equal to f of 0. So f is continuous at 0. at 0. So that possibility is ruled out. Now we have to check if it is discontinuous anywhere else. Now in this is your domain, out of which here if you see, all negative values. Function is going to be of the type f of x equal to x by minus x, which is minus 1. I'm solving, it will come as minus 1. So net effect on this side, also the function is minus 1. Here then it is defined as a constant function minus 1, and 0 also it is minus 1. So like that, even on this part of the number line, function is constant. That part of the number line, function is constant. So there is going to be no points of discontinuity over here. So we can, if you want, we can mention at x less than 0, f of x is minus x. Let me look at the function. It is x by minus x, which is minus 1. Therefore, f is continuous. At x greater than or equal to 0, f of x is minus 1. That is a constant function. You also can write constant function. Therefore, f is continuous. Okay. Therefore, there is no point of discontinuity. No point of discontinuity. That is what we conclude from there. So that's all about that question. Then we quickly move to the next one, and let's see what the next one says. We'll pre-do it here in this lot. 10th question. F of x is given as x plus 1 when x is after 1, and it is less than 1 when it is less than 1, it is defined as x squared plus 1. So let's write this definition. Let's make ourselves aware. This is at 1. It is for me to write, when I come like this and I write like this, it doesn't come out well. Writing becomes bad. But at the same time, if I stand like this and writing is comfortable, and handwriting is also a little better. So that is why I always prefer to stand here. But then in that case, this part of the board gets hidden. So many technical, digital education gives so many problems. When you are in a normal class, the children, no, ma'am, move, that's an instant signal and you just move off. Here means you don't know how much you're obstructing others. So for the time being, I'll stand here and do it. So the domain is like this. For every x which is less than 1 in this area, it is defined as x squared plus 1, and everywhere after 1, it is defined as x plus 1. This is how the definition is. Now, we have to see, as I said, there is a problem around 1. So, around 1 first we will check. Then we will think of other things. So, at x equal to 1, that is what we are doing. Consider the limit as x tends to 1 minus f of x. That means on the left side of 1. It's very clear to us from this figure that it is x squared plus 1. That means you can tend x to 1, very close to 1. 1 squared plus 1. Just if x is tending to 1, very close to 1, you can substitute it as 1. So 1 squared is 1, 1 plus 1, 2. And if you carefully look at limit as x tends to 1 plus f of x, that means on the right side. On the right side, it's very clear to us that it's defined as x plus 1. So x plus 1 means tending to 1 can be 1. So 1 plus 1, that is also 2. So they are okay. How about f of 1? F of 1 is defined as the first definition, that is 1 plus 1. So that is also 2. So what do we have? Limit as x tends to 1 minus f of x is equal to limit as x tends to 1 plus f of x is equal to f of 1, means it's continuous at 1. Therefore, f is continuous at 1. Now, at x less than 1, what happens? F of x is x squared plus 1, which is a polynomial function. Is a polynomial function, so continuous. That we can just mention. Therefore, f is continuous. Then, at x greater than 1, f of x is defined as x plus 1. It is defined as x plus 1. So, that is also a polynomial function or a linear function actually. So, f is continuous. So, there is no point of discontinuity. There is no point of discontinuity. Right? That is how the function is. Now, we'll see if there is a room for the 11th problem. Let's check. we'll quickly take it down. It says that f of x is x cube minus 3. F of x is x cube minus 3 when x is less than or equal to 2. And it is x squared plus 1 when x is greater than 2. So same way, we'll try to do it at 2, and then later on we will check how it is going to behave later and all that. So this is our number line. How is the domain defined? On this side, it is defined as f of x equal to x cube minus 3, and on this side it is defined as x squared plus 1. Around 2 we will first check, and then we will see how it is going to be later on at x equal to 2. Let's check what happens. Consider limit as x tends to 2 minus f of x. That means 2 from the left side. So it's very clear from the definition that it will come to x cube minus 3. So that means it is x is tending to do close to 2, very close to 2. So 2 can be substituted. It is 2 cube minus 3. That means 8 minus 3, which is fine. And we are taking limit as x tends to 2 plus f of x, which means it is x as tending to 2 plus f of x. For us it is x squared plus 1. X is tending to 2, very close to 2, so you can substitute 2 squared plus 1. So that is 4 plus 1, that is also fine. And 2 is taking this value, so f of 2 is again 2 cube minus 3, that's also fine. So it is same from all the sides. Limit as x tends to 2 minus f of x is equal to limit as x tends to 2 plus f of x, and that is equal to f of 2. F is continuous at 2, therefore f is continuous at x equal to 2. So like before, we will check at x less than 2. At x less than 2, the function is defined as x cube minus 2 is a polynomial function. So f is continuous. Then at x greater than 2, f of x is defined as x squared plus 1, that is also a polynomial function. So f is continuous. So f is continuous everywhere. There is no point of discontinuity. Yes. So that's about the continuity of some of the problems. There are many problems in that exercise that we will be dealing in the next video. Thank you.